This is part 2 of the lecture on interaction among independent variables. Let's look at some examples of linear and logistic regression analyses with interactions. There are 3 types of two-factor interaction. First, one variable may be categorical, and the other may be numerical. Second, both variables may be categorical. Third, both may be numerical. Let's start with an example of numerical categorical interaction. In this example, the dependent variable is systolic blood pressure, the numerical variable is age, and the categorical variable is gender. This is a result of linear regression of systolic blood pressure on age and gender, using NHANES data. X1 is age, X2 is gender. The beta coefficients were estimated as follows. 0.513 means that an approximately 0.5 difference in systolic blood pressure corresponds to a 1-year difference in age, and minus 3.250 means that females tend to have about 3 points lower blood pressure than males controlling for age. Now, let's introduce an interaction term. Like in the previous model, we have age as X1, and gender as X2. In addition, here we have a product of age and gender, X1 times X2. Then we get these estimates for alpha, beta 1, beta 2, and beta 3. To interpret the results, let's look at males and females separately. For males, X2 is 0. Thus the third and fourth terms disappear and only the first 2 terms remain. For males, a 0.322 point difference in systolic blood pressure corresponds to 1-year difference in age. For females, making X2 equal 1 in the third and fourth terms, we get this equation. For females, a 0.692 difference in systolic blood pressure corresponds to 1-year difference in age. The beta for age is 0.322 for males but 0.692 for females. This is a substantial difference. What does this mean? To understand the gender difference in beta for age, let's look at this graphic presentation of the regression results. The leftmost figure shows what the results of regression without an interaction term imply. The rightmost figure shows results that imply an interaction. Both figures show the relationship between age and systolic blood pressure. The red lines represent females, and the blue lines represent males. All these lines mean that systolic blood pressure increases with age. In the figure to the left, the 2 lines are parallel. The model did not include any interaction term, which means we assume that the relationship between age and blood pressure is the same for men and women. The vertical distance between the 2 parallel lines is 3.250, which is the beta for the gender binary variable. In the figure on the right, women at young ages tend to have lower blood pressure than men, but blood pressure increases with age more steeply for women than for men. Therefore, after age 60, women tend to have higher blood pressure than men. A possibility for this interaction could be the onset of menopause. The regression model with an interaction term can be expressed in 3 different ways. All are mathematically equivalent, but the first one seems to suggest that there is some special effect on blood pressure with a combination of age and gender. The second equation seems to suggest that the effect of age on blood pressure is different between men and women. The third equation looks to be emphasizing that the gender difference in blood pressure varies with age. The results of statistical inference have shown that the interaction is statistically significant. The regression analysis was done in 2 steps. First, with only age and gender. Subsequently, the interaction term, as a product of the 2 variables, was added. The former is labeled Model 1, and the latter Model 2. Beta for the multiplicative term was 0.370 and the p-value for the beta was very low, suggesting that the term should be included. If the p-value were high, it would suggest that the multiplicative term could be ignored and removed. We would then refer to Model 1, the model without the interaction.